Well, hello and welcome to another DevNation Tech Talk. We're coming to you live today. Basically, I have with me Bill Burke coming out of Massachusetts, and he's going to be walking us through Amazon Lambda and Java and telling us all about the secrets, techniques, and key capabilities you need to be Amazon Lambda ready with Quarkus and a Java technology. So that's going to be awesome. My name is Burr Sutter. I'm coming to you from North Carolina. We, as most of you probably are right now, you're kind of working from home as well. So that's what Bill and I are doing today. But we hope you engage us with this presentation. Feel free to throw questions into the chat room. We'll try to answer them in real time. And then, of course, we'll have some hand over to Bill when he's ready. So at this point, Bill, let's get in there.
All right, guys. Hey, this is Bill Burke. I'm a senior distinguished engineer at Red Hat. Some of the things I've done at Red Hat over the years, I'm the founder of the Keycloak project, the Rest Easy project. Also written a couple of Riley books too on EJB and JAX-RS. And today I'm going to talk about the Quarkus serverless strategy and some of the stuff we have around there. So let me share my screen here. Hopefully you can see this, or interrupt me if you can't see this. So, all right, great. So today I'm talking about Quarkus serverless, specifically with AWS Lambda and Azure functions. So what am I going to be talking about today? So I'm going to try to give a short intro on what I believe the serverless is, what's important about it, what are the advantages and disadvantages. And then I'm going to go into the Quarkus serverless story, and a big bulk of that is going to be a bunch of demos. I'm going to demo on how you can improve basic Lambda cold start with Quarkus and Graal. Then I'm going to do a demo of using Quarkus with Spring dependency injection and a Lambda class. Then I'm going to build a REST service on Lambda with Quarkus and Spring MVC. And if I have time, I don't think I will, I'm going to show Quarkus with the same Spring MVC demo. I'm going to show it on Azure functions as well. So what is serverless? I think the most important feature of serverless is something called scale to zero. The idea is in serverless is that you don't have your service initially running, and it doesn't start running, it doesn't start to spin up until you actually get a request into your system. So that's really what scale to zero is. And what's even cooler about this is that in a serverless runtime, as more and more events come in, it can be configured to auto scale as well based on the volume of your requests coming into your system. So really, that I think is the most important feature of serverless. There's some other features of serverless that are out there in various cloud environments. A lot of them do direct code deployments. So, for instance, Lambda, you can deploy a jar directly to the cloud environment. You don't have to deal with a container, and I think that's a nice simplification. Another thing that some of these cloud environments are doing, they are introducing new APIs and development models that are very fine-grained and event-driven. So why would somebody do serverless? I think that, in my opinion, the biggest reason people actually look at this stuff is to reduce costs. So in the public cloud, if you have a service running and it's idle 99% of the time, why do you want to pay 24/7 for this service to be up? Wouldn't it be nice if you only paid when that service actually ran? And that's one of the key things of serverless that brings you to serverless, to reduce costs. In a private cloud, a lot of these IT managers, they want to increase a density on existing resources so they don't have to either buy new machines or even create a new data center. So reducing costs is one of the biggest reasons of serverless. Some of the minor reasons, deployment is simpler and faster. Like Lambda, you can just build your jar locally and deploy it directly. The idea being that a lot of these serverless runtimes are removing the ops from DevOps. Also, these serverless platforms are inherently scalable, and it's questionable whether this is an advantage or not, but there's finer-grained deployments as well. You can deploy individual functions instead of very large microservices. What do I think the disadvantages of serverless are? One of the biggest one is cold start latency. So if your service is not running when your initial request comes in, it has to boot up, and that boot time can take some time. So if your clients to your services, Lambdas, require a certain response time, the cold start latency might make Lambdas or another serverless runtime a no-go. Another disadvantage is like these APIs like Lambda and Azure Functions, they're kind of too, in my opinion, maybe this isn't really true, we'll see over time, they're kind of too fine-grained. You're deploying just one function instead of a bunch of related functions in a microservice. So initially, the idea is, I guess, that because these are fine-grained, you can get them out to market quick. But what happens when you go from a handful of deployed functions to 100 functions, 1,000 functions? I'm kind of worried that in the long run, these fine-grained deployments are going to be hard to debug, hard to reproduce problems, hard to maintain. Then finally, which I think is not really a technical reason, really a business reason. One thing I worry about is vendor lock-in. If you're coding to Lambda-specific APIs, to Azure Functions APIs, what happens if 5-10 years from now, this cloud vendor jacks up the prices and you can't move anywhere because you've locked into specific APIs? Another thing I worry about. Java has additional serverless disadvantages. So traditionally, Java was optimized for long-running server applications. It was optimized to increase performance at the expense of memory. So a lot of Java deployments have massive memory footprints. And things like Amazon and EC2 and such, they also bill by memory consumption. So Java has a disadvantage there. Another thing is that traditionally, all the traditional Java frameworks are slow to boot. Even Spring Boot, Java EE, JBoss, their boot times are measured in seconds. And if you're dealing with a cold start in a serverless environment, you want to get that down to milliseconds. So Java has a few kind of important disadvantages in the serverless space. Which brings me to Quarkus. So hopefully everybody has heard of Quarkus before or even played with it. But Quarkus is actually perfect for serverless. So Quarkus started about, I think, like a year and a half ago. And the main goal of Quarkus was to take some of our existing technologies and to be able to reduce the Java memory footprint and boot time massively. Quarkus doesn't assume memory is abundant and cheap, and it was designed from the beginning to reduce memory footprint and to increase boot time and cold start latency. So that brings me to the Quarkus serverless vision. So since Quarkus is perfect as it is for serverless because it's low memory footprint and cold start latency, another thing we wanted to do is we wanted to bring the Java ecosystem to places like AWS Lambda and Azure Functions. Popular frameworks that you've been using for a decade, like Spring, CDI, Hibernate, Spring Data. We want to be able to bring those popular APIs so you can use them in Lambda. Another part of our Quarkus serverless vision is we want to sort of break vendor lock-in. And the way we want to do that is to have the ability to write serverless applications that are portable. So that you can use, for instance, you can use popular REST-based specifications like JAX-RS and Spring MVC. And we're also going to be introducing in a few weeks our own function framework that is portable across all these cloud runtimes. Then finally, so all that stuff, that's all pure Java-based. We can improve Lambda and Azure Functions just by bringing the Quarkus ecosystem and all the projects it integrates with. But additionally, we want to leverage Graal VM in Lambda. Graal VM allows you to take a Java program and compile it into a native executable. And I'm going to show you, I'm going to actually demo that today later in a few minutes. Like right now. So before I start demoing here, I want to give you a little disclaimer. So I gave this presentation a couple months ago, and it was about 55 minutes. And a lot of that time was taking actually building and deploying, particularly deploying. So what we're going to do here, I'm going to code up the examples, but I've already pre-compiled everything and deployed it to AWS to reduce the amount of time this presentation takes. So I guess we only have a half hour. I have to reduce this to a half hour, and that's one of the things I did to reduce it. All right. So the first thing I'm going to show is a basic Lambda. And what I want to do is compile this Lambda as is, as you would any other Java-based Lambda, and deploy it. And I want to see the cold start latency and the memory consumption for a basic Java Lambda. And what is our Java Lambda here? Really, really simple. We're implementing a request handler. If you ever implemented a AWS Lambda, that's one of the interfaces that they provide to create a Lambda. And this Lambda is really, really simple. It takes string as input and has string as output. And it's a greeting Lambda. It takes a name parameter and concatenates, prepends hello to it, and just sends back a greeting back to the client. That's all it does. So let's actually invoke this this Lambda. I've already deployed it. And this is a pure Java deployment. Hey guys, in the wrong directory. Make it clear. All right, so you see I'm invoking my greeting function. And let's take note of two things that we got back after we invoked this. One is the max memory used, it's 82 megabytes here, and the init duration. This is our cold start latency. And what we got with the pure Java Lambda, that really simple Lambda, is 300 milliseconds. Okay. Next thing I want to show you is I want to Quarkize this Lambda. I'm going to take this code as is. And I want to compile it with Quarkus and Graal and deploy it as a custom runtime to AWS. I've already done that. I'm going to demo in a second, but I just want to show you what we had to do that. We didn't have to change any code, but in our POM, we had to pull in the Quarkus Maven things that you have to pull in. We were pulling in the Quarkus BOM to our POM. We pull in Quarkus extension, which is a Maven artifact, Quarkus Amazon Lambda, and the rest of the stuff is just POM things you would have to do with any Quarkus project, not just with Amazon Lambda. There's a Quarkus Maven plugin for it. So I've actually already built this with Graal and deployed it to Amazon. And now what I want to do is I want to invoke this. And I want to show the difference of the cold start latency. Probably shouldn't have cleared the screen. Oh, well. But anyway, so if you remembered our init duration before, it was 300 milliseconds and about, I think, a little over 80 megabytes. And if we look at the Quarkize version of this that was built with Graal and turned into a native executable, you see our init duration was cut more than half to 145 milliseconds. And our memory usage was cut down to 46 megabytes. So just by introducing Quarkus and Graal, we cut our cold start latency in half. We almost cut our memory usage in half as well. So that's great. Next thing I want to do, next demo I want to show is I want to pull in Spring dependency injection and actually create a Spring component. To do that, I'm going to go to my POM here, and I'm going to pull in one dependency. Quarkus, let me enable auto import. I'm going to pull in Quarkus, Spring, DI. So this is a Quarkus extension that provides integration with Spring dependency injections so that you can write Spring components and use Spring injection annotations. So let's go to our Lambda. So what I want to do here is this message here, this message generation, I want to turn that into a Spring component. So let's do that. I'm going to create a new class, greeting service. If you got I bet you most of you have done Spring before, so this will not be new to you. We're going to make this a Spring component. Public string greeting, string name, return hello plus name. That I'm going to go to back to my Lambda, and I'm going to inject. So what's happened here is this Lambda now is also a Spring component. It can accept injections. I'm going to inject that greeting service, and I'm going to return service.greeting name. All right, so we've created a Spring component. We have injected the Spring component into our Lambda class, and now we can execute it. So let's actually do that. Lambda demo, sh invoke.sh. So we're invoking our Quarkus Spring greeting function. And let's look at our memory used and our cold start latency. So our init duration went up to about 900 milliseconds. So this is because we are bringing in Spring, we're creating components, we're doing all this initialization at runtime that we need to do for component layers. So we're doing a little bit more. We have a little bit more code here and a little bit more libraries here, so our init duration goes up. Our memory usage went up to 100 megabytes as well. All right. So I can take this existing project here, and I can compile it with Quarkus and Graal into a native executable and deploy that to Amazon. I've already done that, so I'm actually going to invoke on that, and we're going to hopefully see a difference here. So if you look at our init duration, it went from 895 milliseconds to 134 milliseconds and 54 megabytes versus 100 megabytes. So you see our init duration is about the same as when we just wrote a vanilla Lambda with Graal and Quarkus. So pure Java with Spring and Lambda was about 900 milliseconds for this simple example. We recompiled with Graal and we got down to 134 milliseconds. Okay, so what was another disadvantage about Lambda in these serverless runtimes? Vendor lock-in. Again, what happens when these companies can't grow anymore and the cloud market is saturated? What are they going to do to grow their earnings per share and revenue in a quarter when they need to do that? There's no more customers left. 5-10 years from now, I guarantee these guys are going to start jacking up prices. And they're going to be able to do that because a lot of people are going to be using Amazon APIs, Azure APIs, and they won't be able to move off of these platforms because they're locked in specifically to the code as well as to the operations. So how are we going to manage that in Quarkus? So our vision here is two things. One, we want to push REST-based services that can be deployed to Lambda and other cloud environments. That's going to be our primary push. And in a few weeks, we're going to introduce a function framework for Quarkus that is portable across all these cloud runtimes. All right, so what I want to demo now is I want to take this Lambda, make it portable across cloud runtimes, and turn it into a REST service. And what I'm going to do is I'm going to convert it into a Spring controller, a Spring MVC controller. So to do that, I have to pull in two new dependencies. I have to pull in Quarkus Spring Web, which is our wrapper around Spring MVC. And I also need to pull in our integration layer between Amazon and our HTTP engine. Amazon Lambda HTTP. So that's all I have to do to change my POM here. Let's go to our Lambda. first thing I'm going to do, I'm going to get rid of all the AWS specific code. Remove the imports. Get rid of our request handler. Get rid of the context interface that's Amazon specific. And now we're going to turn this into a Spring MVC REST controller. Now, I could use JAX-RS via REST Easy. I could also use Vertex Web. You can even write a servlet and deploy it as a Lambda with Quarkus. All right, so let me finish this off here. I got to provide a path for this service. It's going to be /greeting/name. There, a query parameter there. The method is going to be it's going to be a HTTP GET method, and we're going to produce text. And then finally, we have to inject the name parameter with a path variable. So this is all Spring MVC. Again, I could use JAX-RS if I wanted to, servlet. Ooh, am I spelling that wrong? Oops. Yep. Path variable name, string name. All right. So there we have it. We have our Spring MVC controller. And before I actually demo this with Quarkus, I want to demo it with Spring MVC, pure Spring MVC without Quarkus on Lambda. You see, Amazon has a GitHub project that AWS Labs did where they actually integrated Spring MVC, JAX-RS, and other HTTP frameworks into Lambda. And I actually want to demo that first. First, I want to show the code differences. So this is our Quarkus project. You see, we just wrote our REST controller here, and we have our service. We have no other code. Let's look at the AWS Labs pure Spring MVC integration. It's the same Lambda code. It's the same service. But additionally, with that AWS Labs GitHub project, you have to write some boilerplate code. One is you have to write a request stream handler that bootstraps everything. You don't have to do that in Quarkus. Another thing that you have to do is create Spring API config. And this code was copied directly from their example. I didn't write this code. But one of the interesting things here is they actually manually import all of their components they want to import. So they import the Lambda class and their components. And this comment that they have was interesting. They said, we use direct import instead of component scan to speed up cold starts. The thing about Quarkus is we do component scan. And we do component scan at build time, so it does not hurt boot time and cold start latency. So you don't have to do direct imports with Quarkus and Spring because we do component scan at build time. All right, so let's actually demo this. All right. So I have a browser here. On the right side here, I have Chrome Developer Tools, and this will show me the time of the actual request I make. So first, I want to invoke on the pure Spring MVC endpoint that's deployed on Lambda. This pure Spring MVC does not have Quarkus within it. First, I have to get the URL. All right, there's the URL. Copy the link here. See that, hopefully you can see this small text here. This is the URL and /greeting/bill if you remember from the code. So this is running. It's going to take some time because it's got to do some cold start. Cold start is a little bit longer with the REST service. I'll talk about that why later. But for this pure Spring MVC without Quarkus, just pure Spring MVC on a Lambda, the cold start latency is 7.35 seconds. All right. So next, let's run the Quarkus REST service that I did. The same exact code, except it's integrated with Quarkus. I have to get the URL again. What's the URL? And this is a pure Java execution. All right, so copy the link. Greeting / from Quarkus, Java, pure Java. Oops. All right, there we go. All right, so I'm executing this. This is gonna be a little bit faster. So my message was hello from Quarkus Pure Java, and the cold start latency is a little bit better. So before the cold start latency with pure Spring MVC was 7.35 seconds. This with Quarkus it's 4.49 seconds, and that's pure Java. Next thing I want to show is it with Graal. So I compiled this application I did, the Spring MVC Quarkus application, into Graal native image. Let's get the URL for that. The link here. Greeting from native. This can be a lot faster. So with Graal, the native executable, this took 1 second. So we went from 7 seconds with pure Spring MVC on Lambda, down to 4 seconds with Quarkus and Spring MVC, down to 1 second with Graal native image of Quarkus and Spring MVC. All right, I'm starting to run out of time, so I'm going to go a little bit faster here. All right. I'm not going to have time to demo this same exact application on Azure Functions, but it will work. And I think Burr's going to provide the links. We have some guides and that walk you through writing a demo application, really the exact one I just did here. You can do a guide that we have online. So to break vendor lock-in, we wrote REST services. In a few weeks, though, we are going to introduce Quarkus Funqy FAS framework. We might change the name. And the thing with that is we're going to have a function API that is usable across all these cloud environments. This is what it looks like. It looks a lot like Lambda. You annotate a method with func, and it has an input and output object. And this will work on various cloud runtimes. All right, so that's about it for my presentation. What did we learn today? One, taking Amazon Lambda, Quarkizing it can speed up cold start latency and memory, just as is. Take the code as is. We can bring in the Java ecosystem. We can bring in the Java ecosystem, and we brought in our demo. We brought in Spring dependency injection. We can break the vendor lock-in of Amazon and create REST-based services. And we can build these REST-based services with Spring MVC or JAX-RS or Vertex Web or Servlet. And we can even compile these to a native executable and to improve our memory consumption and cold start latency. So that's about it. I think, Burr, I can answer questions on the YouTube thread or something. Is that how it works?
Let's take a couple more minutes because there was a couple of great questions that came in. Like from Valentino in particular, he basically was saying, I want to use S3, but S3 with Micronaut is a pain, and CQRS is also buggy. So have you had a chance to try S3 integration with Quarkus and Amazon Lambda or CQRS?
I personally have not, but we do have an extension for that. The setup is probably quirky as well, but we're working to improve that because like S3 requires you to invoke on S3 via HTTPS, and there's some. If you're doing native, you have to include actual an SSL library with the deployment. So, but we're working to improve that to make it one build.
Okay. And then, because I wonder with S3 thing, if we could also use the Camel extensions that can be integrated with Quarkus to then also talk S3.
I see no reason why you can't do that, because what we've done with our Lambda integration is we pulled in the Quarkus echo, and anything that Quarkus integrates with should run within Lambda.
Okay, I was looking through the list of extensions.
Yeah, really anything that doesn't expose a network connection itself. Like you can't run an HTTP server within the Lambda instance.
Okay. And then another great question that came up early that I think if you could address, what is the right granularity of function design versus microservice design? Should I take my microservice and blow it up into 100 functions and try to deploy them all individually? What would you say the right strategy is from your perspective?
All right. If you ask somebody else, they would say, break it up into functions. That's the new way of doing things. My personal opinion is I really, really worry about breaking things up into fine-grained functions, which is why, like, to look at the REST example, we could have had 10 endpoints deployed as one Lambda. So there's no reason you can't deploy a full microservice, a REST-based microservice to Lambda. And my personal opinion is I would rather do it that way. One, to not use the Amazon APIs where possible, and to group things together, because I feel like I really worry in the future that once people get to 1,000 Lambdas, it's going to be unsustainable. That's just my opinion. Others will disagree.
No, I was even chatting in the live chat as well on that same topic. I also think that you should think in terms of what your public API is, and then also what your internal API is. Meaning, if you have all these methods and functions that are part of your application base that have no public API, meaning they're not to be consumed by the outside world, I see no reason to expose those functions. Just let them stay internal and in your just another jar file in your application.
Like, I mean, I have run into cases when I've written applications where there are things that are just functions. Like a good example is like batch processes and stuff, or like management functions that may only run once a month. Those may be good things to do as functions, but I'd rather group them. Personally, as a developer, a maintainer of projects, I want to group things together where it makes sense.
And have you ever tried Amazon Fargate?
No.
Yeah, I haven't either. So that would be an interesting one to see exactly what we could get out of that. And then, so Fargate is another way to run containers, but that's not really Lambda. So it's just another way to run containers. So a container is a container. So it should be fine on the Fargate side of things. And then API Gateway. So you showed us REST. So what is your position on Amazon API Gateway?
What I didn't have time for was how did we actually implement the REST service behind the scenes? How does Quarkus implement it? Number one, we actually depend on API Gateway, because what API Gateway can do is map HTTP requests to a Lambda, and we leverage it within if you actually went on the Quarkus website and went to the Lambda REST example, it actually says, oh, you're going to use API Gateway. You're going to use SAM to hook it up together, and you're going to deploy it. Hope that answers the question.
So, and I think that's all we really have time for. I apologize there might have been a couple more questions in there that I missed. But otherwise, Bill, I really enjoyed the presentation, showing that cold start latency drop, based on going from regular JVM, old school Spring Boot, classic development model to the new Quarkus model. Seeing things vastly smaller, vastly faster, right? What we call supersonic, subatomic is pretty awesome. That was pretty cool, man. Thank you.
Thanks, guys. Everybody have a good day and stay safe.
Yeah, everybody out there, stay safe. And Bill and I are out of here. Thank you so much.